In section 2.6, we're going to be looking at what's called function notation for linear functions. So what we're going to look at, and you may not have seen this before, is instead of writing an equation like y equals x plus 2, as we have in the past, we'll swap the y with a new notation. We'll swap it with what's called function notation, which looks like this f with a parentheses around it, x. But everything else, the x plus 2, everything else will be the same. And it will mean exactly the same thing. We're just swapping the y for this new f with the parentheses x. Okay, so why would we do this? It's not just to make your lives harder. Well, we wanted to be able to distinguish one function from another. So we don't want to call our functions y. That'll get really confusing. So now we can call one function f, one function g, another one h. They're almost like a name. It's an identifier. This is your identifier. It also gives us a possibility of quickly being able to ask for something. Right now I'm leaving the x as an x, but if I said something like find f and we put inside the parentheses a 3 instead of the x, what that would mean is to take that 3 and plug it in wherever there's an x. So it gives us a quick way to tell us whatever's inside here is going to get plugged in for x. So, and then whatever comes out that it equals will be your y value. You'll get some kind of number out that'll be a y value. So you're plugging in an x and getting out a y, just like we've done before. It's just this new notation. So how do you read this new notation, this f with the parentheses around it, the f with the parentheses around it, and the x? This is read, if you were to read it like a sentence, f, and then the parentheses are read of, and then x. That's how you read the function notation. So let's go ahead and try and use it. For this first example, they tell us they want our function f of x to equal 4x plus 3. Then they tell us, first of all, to go ahead and find f of negative 2. So if they're trying to get us to find f of negative 2, they're telling me whatever's inside these parentheses need to get plugged in for x into the function wherever there was an x. So the 4 will stay the same. The only thing that's going to change is that x is going to get replaced with that negative 2. Now, I love this notation because the parentheses around the negative 2 should also be a reminder that whenever you plug things in, you always put parentheses around it. So take that whole negative 2, parentheses and all, and plug it in wherever you see an x. Then you have that plus 3 at the end, which is going to stay the same. Now, all you have to do is follow order of operations. Order of operations is going to tell you to do your multiplication first, the 4 times negative 2, which is negative 8. And then we've got the plus 3. The plus 3, which is negative 5. And that's our final answer. So when my math lab says, what does f of negative 2 equal? You'll just input the answer, negative 5. But what this actually means is if you plug in an x value of negative 2, you get out a y value of negative 5 into this function. Here I'm starting to get confused, so let me kind of line that off. In B, they want us to find f of 1. Same idea. So we take our 4 that was out in front of the x, then we replace our x, just like before, with a 1, just like the last one. If you plug in anything for x, don't forget to make your plug in with parentheses around it. Then our plus 3. Our order of operations, just like last time, is going to tell us to multiply the 4 times 1 first, which will give us the number 4. Then we'll do our plus 3, which will give us the value 7, and that's our final answer for this one, is if we plug in 1 for x, we get out 7 for y. Now this next one, C, looks a little funny. That is not a typo. That is f of a. And what that's saying is replace any x's with what we've got here, which is an a. So it's going to be 4, and then the x is going to get replaced with an a. And then we have our plus 3. Remember, we left the 4x plus 3 as 4x plus 3 because the 4x and the 3 were not like terms. You couldn't add them. The 4a and the 3 here are not like terms. You cannot add them. So this is it. All you can do is replace the x with an a. You can't actually add or subtract anything because there aren't any like terms.